Hello, everyone. We are live. Finally, this has been several months in the making, and I'm really excited to have Ari Kaplan with us. We're going to give Ari his full introduction in just a second. I'll just briefly introduce myself. My name is Serge Gershkovich. I'm product success lead at SqlDBM. And Ari, I'll let him add any details that I might miss because you'll see that this is quite extensive. And I had to actually write these down. So let's read off about Ari. Who is he? So Ari is a leading analyst and technologist, or he has worked as one for Major League Baseball, having worked with 11 clubs. He has traveled the world with McLaren Formula One, assisting the racing strategy team to bring AI models to production. He has worked as a major league scout and a music scout. Ari received his bachelor's degree in engineering from Caltech and was awarded the school's prestigious Alumni of the Decade distinction of the decade, not magna cum laude, but 10 of those. And he was also mentioned in Crane Communications 40 Under 40 profile of business leaders. He was CEO and CTO for Expand Brand Corporation, which was acquired by Datalink. Ari has been, we can go all day. Ari has been covered in more than 400 print, online, and broadcast outlets, including the Today Show, CNN Time, etc. Awarded broad patents on mobile technology with 46 claims. Served as a technical evangelist for Data Robot and now Databricks, where he is now lead head of evangelism. And I say this not to make you blush, Ari. It's quite an accomplished list. I say this to ask the following. As impressive as all that sounds, you didn't just coast into these jobs. So from what I understand, the Dodgers, which was your first major league experience, they called you in your dorm room. So while you were still in college. And as we say in sports, we need to discount luck. So what I'm really trying to ask is, there's many people that work in AI, ML, data, architecture. What has been the common thread from that very first phone call to the stellar career that you've had? What is it that you bring to data, or data speaks through you, that has made all of this possible? Starting you off with a softball. No
this is
pun
great.
intended.
Well, thank you for that great introduction, and it's so nice to to finally do this webinar. We've been seeing each other all over the world, and also wanted to say hi to everyone listening in. I appreciate your time, whether it's live or in the future recording. But I've been honored to have a pretty wild career, and like the latest one with Databricks is going to be another incredible adventure. But yeah, that story from the very beginning, and it seems like every 4 years, like almost the length that you go to high school or college, you have to reinvent yourself. The technology changes, or things of that nature. One thing that's been a theme in terms of career, a lot of people in the world see a job opening, they apply, the company sees if there's a fit or not, and they try to get that perfect match. But like one theme, at least from the career wise, was almost all of my jobs throughout my life have been something that wasn't an actual job opening. So from the beginning, when I got that job with the Dodgers, mind you, I was still a teenager, which was incredible. I went from being a fan to having the general manager. He saw me in the LA Times article, looked me up. We didn't have cell phones back then. Just called my dorm. I was sitting there, and my housemate said, "Hey, the Fred Clare, the GM of the Dodgers, is on the line. He wants to talk to you." And there were a lot of pranks at Caltech, but I don't know, the way they said it, I just it just seemed real. So I talked, and he said, "Oh, I saw you in the, what you're doing with player evaluation. I think you're onto something, Ari." But like, he didn't hire me like right on the phone. He goes, "Can you get to Dodger Stadium in the next couple of weeks to to meet, and we can, I want to learn a little bit more from you. Maybe it can help. And I'm like, I will be there within 2 hours. I had no idea if he changed his mind, got busy, traveled. So I just got out there, and I went from being just like a fan who did some cool statistical analysis that looked promising at the time, to being in the dugout, Kirk Gibson, Eddie Murray, Hall of Famer, Oral Hershiser, future Hall of Famers were all there, and they're extremely interested. But the point there is, there was no role there. I was one of the first 4 people that we know of that were employed by any sports team, and now for the role of what we call now analytics, data engineering and data analytics. And now there, it's a market of tens of thousands of people. And then, similarly, we could go through career progression, but most companies, it's a role that kind of plays towards my strengths. So that's one kind of career advice, or if people are in the hiring mode, is, look at the person in front of you, and if they have some unique talent or ability, maybe draft the role. And, here at Databricks, I'm sure we'll rewind and go through a little bit more of it, but the term data or evangelist is somewhat newish. It's kind of a funny name. Some people think it's like a religious thing. Definitely not. But it is a growing technology thing, which kind of like a brand ambassador, somebody to help spread the word of why and who and how to new personas, or to people just never heard, in this case of Databricks. But that, that was something that they didn't have a role for. So it was just like the right time there. And then, I don't know if you're alluding to in terms of what you can bring to the table. So there's a skill set of software development, like Python, R type of programming. There's a skill set of math and probability. There's a skill set, which is, I think, where people should be headed, which is domain expertise. So in that, where SqlDBM is super important, is you have an application you want to build or some way to represent data. If you don't know the business, you won't know what, an entity or relationship, you won't know how to structure and store the data. But if you do know, you'll know what type of data you want to capture, or as the business changes, what type of new data you want to capture and how you want to join it all together. So, from that perspective, one of the successes I've had, as well as a lot of other people, is just really diving in and understanding the business that you're in, and then figuring out how do you take the real world and encapsulate it into a structure that encapsulates the data as best as possible.
Yeah, absolutely. So part of the reason why I was asking was kind of what you alluded to, that the common thread is just being well-versed technically, but also being a subject matter expert that you can actually ask meaningful questions. And I guess it's normal to you that the Dodgers are calling you up in your dorm room just because as a teen you'd already been published in major news outlets. But can you rewind that and tell us how you got started in data or engineering? Because I saw somewhere that you were writing programs to write poems in 5th grade. Is that true?
Yeah, that was fun. Which when I do this generative AI, I blast back to when I was a little kid. But yeah, it was and you could do prompt engineering. I would, I had 3 or 4 bands. So it's write poetry just straight out, write poetry as a haiku, write poetry as a Beatles song, or a Beatles style. And it would kind of adapt. And yeah, I had word dictionaries. At the time, I got the idea. I was working at ETS when I was I think at that point, high elementary, low junior high. They're the people that make the SATs and ACT tests, and making data dictionaries of Spanish words to English so that they could do a test bilingually. It was more fair to have the test not in English only. So yeah, I got that idea writing these database compression algorithms back then. But yeah, that was pretty wild. It was, like they have the famous Turing test. It was like, how can I take data and make, language that was, you couldn't tell a human wrote it.
Exactly. So, but when did you get interested in this, or what was your foray into programming and analytics?
Yeah, ever since I was a kid, I think human nature has always had a fascination to take the real world and kind of digitize it, like whether it was the field of chemistry before computers even came out, or physics. How does gravity work? How does magnetism work? And now everyone in every industry is trying to take the real life world and put it, virtual reality. I'm a big aficionado of that. But like with data itself, you just started out as a young age, wrote what are called bulletin board services, which is kind of like before the internet, wrote and sold video games. And it was just like a passion of mine. And then that data turned from like programming and having fun, like writing video games that would be fun enough for me to play, my own games, all the way to like the math of sports. And like the real start there that kind of led to the Dodgers was looking at games as a fan's perspective and seeing on a broadcaster, getting these baseball cards and seeing this one player I liked didn't always have good statistics and vice versa. And everyone would complain, like batting average, wins and saves. Those are like, unfortunately, still are common statistics.
Mm-hmm.
But instead of complaining, or in addition to complaining, just came out with a better way to explain it. But most importantly, kind of like your opening question, being able to explain it in plain terms. So like a typical baseball fan drunk in a bar could say, yeah, that's right. So the thing that got super popular back then was the letter X, which is still in use today. So X stands for expected. So when you see expected goals in Premier League or expected wins in any sport, it was kind of taking out the luck and saying, what were you expected to win? So I think the main thing is, someone like a Dodger GM could take that and say, that makes sense. I want to get players based on what I expect them to do, instead of based on what, maybe luck influenced them, 30%, of the variability.
Okay. So I actually have a couple of questions, and let's linger on that, because when we announced that we were having you on, we got, I'd say, just as many baseball questions as we got Databricks questions, and I promise we're going to cover both. So let's just linger a little bit on sabermetrics. So Ari, those that don't know, he has worked directly with the Jedi Council to optimize lightsaber design and performance. So according to my notes, that's accurate. You can fact check me on that. So going back to what you just said, for those that don't know, sabermetrics is the science of baseball analysis and statistics. Ari can give a much broader history than I can. But when you said that, for example, that players that you liked weren't as highly rated, or their stats, they weren't picking the right statistics. And for those of you who have seen the movie Moneyball, and who hasn't at this point, this is exactly what we're talking about. However, in Moneyball, it's framed in exactly the opposite way of, you're saying that you had a perception and the stats didn't support it, whereas in Moneyball, it was the other way around. It was people's, you kind of felt that they were better than they were, whereas in Moneyball, it was they're worse than people are saying, just based on, the ball pops off his bat and things like that. So let's put something measurable on it. So before you even began to analyze data, what gave you that intuition that these players are underrated according to you?
Yeah, well, looking back, I would just call it common sense. So Moneyball, was that like 2003? So we're talking like 14 years before that. Like common sense was like how the statistics were calculated. What are they actually measuring? So there's like ability that players have, which I think is like Moneyball. But then there's how you actually write a math formula to express that. So my beef was with the math formula. So for example, in batting average, it did not even include how many walks a player has, or sacrifice fly. And to get a walk or sac fly in baseball was really important. And it also counted a home run, which is really good, to the exact same as like a base hit, which is also good, but not really good compared to a home run. So like the scale of the measurement that they were doing just didn't make sense, common sense. And then for relievers, it was really not just how they were measuring it, but how the rules were made. So there's something, for example, called an earned run average. Even today, 2023, that's how pitchers are generally judged. And if you're a starting pitcher, and there's a rule in the game that you could like load the bases, allow 3 runners on, leave the game, a substitute for you comes in called the relief pitcher. And at that point, statistically, if that second pitcher comes in and like Serge, you come in, you're awesome, you get out of the jam and none of those 3 runs score, me as the first pitcher, I'm clean. None of them are charged to me. If another pitcher comes in that's not you, Serge, and sucks and all 3 score, then they're all charged to me as the first person. But I have no control over what happens after I leave the game. So if you look at the end of the season, that could affect the starter statistics 10, 15%. If you look at the reliever, your main job is to not allow those runners to score. You come into the game in a situation, 3 runners on, and the earned run average does not factor at all, 0% of how you hold those 3 runners on or not. And that's like the crux of the game. So there it was like just how the rules were defined, how you measure it. And then, so that was it. That's what got me in the game. And then after that, the statistics kind of morphed into how can you actually measure like mechanics of the play.
Okay. So as you know, SqlDBM, we're based in San Diego, California, and we do have a couple of baseball fans on the team. So I would be remiss if I didn't honor their requests and see if you can field these kind of on the fly. So the first one was as a Padres fan, and you've worked for the Padres, so you might even have insider knowledge. This is from Hannah, our head of support. As a Padres fan, this season hurt, and many of us think it was the clubhouse drama that tanked what could have been a great season with top performers. What is clubhouse chemistry worth, and will we ever be able to quantify it?
Yeah, so great question. Hi, Hannah. Yes, I worked with the Padres, in 2 stints. One was back during the Tony Gwynn days. I was special assistant, or I guess you could just say, assistant to Joe McIlvaine, who was the GM at the time. Got to reunite with him with the Orioles many years later, but during the days of Tony Gwynn and Benito Santiago, I still have over there in my bedroom the keys to Jack Murphy Stadium, which was super fun. It was great to see them back then. Tony Gwynn, the nicest and best hitter that I've ever had the honor of working with. And then, when the new ownership was taking over, they had been, part of the Dodger ownership family as well. So, helping, with the advisory there. But then, with the Orioles, I also had the chance to work with Manny Machado. I think he's great. He ended up with the Padres, and I just watched the Padres, so I was thinking the same thing. They were playing the White Sox here in Chicago this past weekend, and I was looking at, like, they have some great young players. So Soto, Acuna, and then not young, but Machado and others. I'm like, wow, those 3 players, I forget the number, but let's just say over $80 million this season spent on it. So it's frustrating when you kind of go all in and assemble what appears to be a great team, which traditionally is young players that are amazing, partnered with like older veteran players. But yeah, I haven't looked at the Padres, honestly, significantly enough to say specifically But yeah, in terms of clubhouse chemistry, that is a big deal. You want people to, it's a team. On one hand, a pitcher is like individually throwing, maybe interaction with a catcher. That's a big deal. But it's very mental, grueling, as well as physical to be in baseball. The game itself is a little shorter, 2.5, 3 hours, but your practice and stuff like that, it's like 7 hours a day plus travel. And if the chemistry is bad, if people are complaining, if the media is asking too many annoying questions, kind of wears down on you. But then there are some players that are really bad that kind of break in and split up, just like the casual, going from everyone having fun to everyone having to watch what they say. And it could be a player, it could be a manager, where a manager kind of listens in and the players have to have their conversations away from the manager, like an eavesdropper. But I don't know if there's a way to mathematically quantify it. So from there, I think you have to use your intuition and talk to coaches and players. The one thing I could say, let me backtrack a bit on that. So one of my claim to fame was recommending Hunter Pence get called up to the majors. He, if you don't know who he is, became the captain of the San Francisco Giants, had a really good career. But when he was in the minors, half of the scout who was with the Astros, I was working with them, said he is major league quality, let's call him up. The other half said, no, his body type, he's too skinny, doesn't have body muscle, he'll get overpowered when he gets to the majors. And of course, the owner and the GM, I was in a room with about 20 people, look at me and goes, Ari, you're the tiebreaker. What do you think? Call him up or not? And I kind of gave the non-committal answer. I'm like, this is too important. I don't want to just use what I think right now. Guys, give me a day and I'll let you know. I'll give you an answer now, but let me really think about it. And they did. And the way I was able to quantify Hannah's question was, didn't really have to do with the chemistry, but it was more as a person, would they listen to constructive feedback and make adjustments or not? The way I was able to quantify it was how Hunter Pence would perform against the opposing pitcher the first, second, third, fourth time they faced each other in a game, and the first, second, third, fourth time they faced each other in different games. Was he adjusting better or the pitcher? And how did that compare to other people in the minor leagues? And I saw that Hunter was in the top 1 or 2% of being able to adjust. So while that isn't directly chemistry, how you relate to each other, it does show you are a humble enough person to take feedback and try to make changes. And that's super important, since if you don't make changes, unless you're insanely good and have incredible, you're like an all-star, you have to make changes in the major leagues or you're going to be out of luck in a year or two.
Okay. That's fantastic. And I want to slowly, not directly, but slowly start steering this back to data and analytics and Databricks. So let's round off baseball, and we might come back to it at the end, but
sure.
What does the state of sabermetrics and scouting, what does it look like today, given what we've learned? Since part of data analysis is not just to build a pipeline, it's to re-inject the results back into itself for iteration and improvement. So is it safe to say that 100% of teams are now on board with that type of statistical analysis? Have the metrics themselves been improving, and are you still finding new ways to optimize?
Yeah, great questions. And in life, you always say, oh, I think everything that could be invented already has been. And then Gen AI comes up, or some, other, Lakehouse technology comes up. But with baseball, it started out, when I started with no data, I had to hand watch games and enter stuff, largely stayed the same until pitch collection technology started in about 2006, 2007, everything going on in the field. You're like, how can it get better from there? You can measure exit velocity and where the pitch was located, automated for every game. And then something called StatCast and Hawkeye came out just pre-COVID, so just like 4 or 5 years ago, which measures like everything, including the limbs of the players in a game. And then just last year, the next iteration of that came out, where it's 300 frames per second, everything happening on the field. So starting a year ago, you can now measure how quick is the bat swinging, or the batter is missing by an inch above or below, to such an extreme degree that like we're just getting started. Since we only have 1 year of data and it's only in the majors, it's now moving to the minors. I've noticed you need like what I call a life cycle of data. What factors, like if you're swinging in a certain way, how does that change as you age? So we're going to need at least 10 more years of data to understand how players develop as humans. What gets you stronger or less strong? Serge, I can't see you getting stronger. You look pretty good there, but do you peak at age 27? How does that affect things? So things are like really taking off.
That sounds outdated in my case. The numbers don't support your analysis.
Very funny. But no, there's a wealth. So now teams, the Yankees, the Rays have 40 or more people in their data engineering / data analytics team. And their wearable technology, and it's just getting better and better. Weather technology, how the wind is like curves in and out at Wrigley Field, which can affect which pitcher to bring in, or how you change the lineup. If it's blowing out, get a ground ball pitcher. If it's blowing in, get fly ball pitcher.
On a second, just so we're on the same page, you're saying you can actually say to a business user, I'm going to get this data, I'm going to get this report to you in 10 years. I don't have enough data right now. They're okay with that? It's never occurred to me to use this excuse.
Yeah, no. I was saying that like if everything's already been done, like we're still going to be learning things 10 years from now on the data. The data, mm-hmm. Some questions, you're exactly right. If a GM were to tell me what biomechanics based on Hawkeye data age well from the minors to the majors, I will have to say come back in 10 years. Okay. But right now there are other questions that could give great answers to.
Okay, so there's questions, for example, like we've been saying, we can use data and statistics to analyze sports. We can obviously, we've been using it in business intelligence to predict business performance. Might data also be used to find missing prisoners and political exiles?
Oh, good one. I have just a story for you. But yeah, no, so data analytics could be used everywhere. There are of course places not, but yeah, that's been the other honor for me is like using data and information to try to find prisoners of war and missing in action people, all granted by have access, in my case, to Soviet era and Ukraine and other prison system and labor camp, Moldova and others, information, and I'm piecing together who could be eyewitness to these missing people. So that's been another honor. Still to this day, I'm now the president of the investigation of the fate of Raoul Wallenberg, who was a Swedish diplomat turned into a hero to rescue tens of thousands of Hungarian people during the Holocaust, but then disappeared and said to be one of the two biggest missing people mysteries of the last century, Amelia Earhart and him.
And is this purely a curiosity project, or is there something personal? How did you get involved with this?
Yeah, well, growing up in Lawrenceville, New Jersey, not far from Princeton, just a lot of the people that were neighbors were rescued by him, or their family rescued by him, then moved from Hungary to Lawrenceville, New Jersey. And the people, he had a staff of hundreds of people that worked with him too. So some people who would like literally risk their lives, heroically jumping into water to save people who are tied in groups of 3, and somebody shot, and the 1 or 2 remaining people, untie them, drag them in like freezing water. Of course, I've also moved to New Jersey, So like they were like trying to find out what happened to Raoul Wallenberg. People had access to vast archival data, but they didn't have programming skills. So in this case, my mother was bragging about me, saying, my son is great with databases. Maybe he can help. And I would say there's so many people that could have done what I did, but just being, in that place, yes, I could take all this unstructured or structured data of prisoner information, interrogation information, transportation from one prison system to another, information, put it in the database, and then do analysis to find, potential eyewitnesses, potential patterns of how they would group prisoners together to try to find out, where was he, where was his driver, and so on.
Wow. So I'm sure you get this question a lot, but given the kinds of things you were doing back then, earlier on in your career, and given the kinds of things as technology evolves possibilities that it unlocks, let's talk specifically about Databricks and let's start first of all with your experience, and if you can start over and start tackling these things from scratch, how would you use existing Databricks? Which functionality would come in handy that you would have been impossible in your day? And after that, I'd like to also get into, without revealing any names or public information, as the head of evangelism, I'm sure you see a lot of very interesting use case that your customers publicly and privately share. So to give people an idea of what's already being done, and actually there's a few more related questions, so let's just take it in order.
Well, great. So just high level I know this is a great mashup of Databricks aware people and SqlDBM aware people, and hopefully people who don't know either of us. So Databricks, super exciting company to be a part of. We, our founders were legends in open source. They created Apache Spark, ML Flow, Delta Lake. If you're not familiar with it, that was the most eye-opening thing when I joined, that those three open source software get tens of millions of downloads every month, hundreds of millions every year, actually over 1 billion per year. It's huge. Go learn on that, taking over, massively parallel computing and managing all that. So Databricks was built on top of these open source, and we created this whole new industry. A lot of companies are getting into the space, but it's called the Lakehouse. Databricks is like the best Lakehouse is a Databricks Lakehouse, but that solves the problem that I personally faced, not just with sports, but with any time I did data science for any of my clients. And that challenge is you have traditional databases and data warehouses, which are largely structured. So think like Oracle and SQL Server, things like that. And then in more recent years, you have a data lake, which is think unstructured data, images, video of the baseball players, PDFs, Word documents, and that's like less governed. If you heard the term data swamp, kind of like that. It's just like a dump of files and stuff, very incompatible systems. And when you're doing predictive analysis, for example, what are sales going to be like, or which customer is likely to churn, the best analysis is when you have some structured data, like customer analysis. What did they buy? When did they buy it? What is the price point they bought it? What store was it in? With unstructured data, did they write a review? Did they do something on social media? So the more variables that you have, the better the predictions are. So the Lakehouse finally is one platform where you can store and manage structured and unstructured data together. So that's the Lakehouse. And then on top of it, there's what we call Unity Catalog, which is largely governance, audit trails of what's happening, but also like insights, transparency of where is your source of data? Is this data from 20 years ago? Has it been updated 5 seconds ago? So like you get that visibility, the transparency, the ability to collaborate together. So that's our Unity catalog. And both of those would have been so useful back in the day, just like the simple, like the initial step. How do you ingest data? How do you engineer data, like transform it? So you join different data sources. And then how do you explore the data? And then how do you make predictive analytics? So like in baseball, we have this biomechanical. What's the sequence when you raise your hand to when you like put your fingers on the ball where the seams and then you throw it? And what does the end result become? That would take months of work to like mesh that all together. You just want to, instead of spending 90% of your time doing the boring, time-consuming part, you want that to be as smooth and simple as possible and be able to work on like the actual use cases and deploying and monitoring your models.
Okay, so let me share my screen because I want to ask a question, and then we'll translate it and direct it to specific use cases. So the question is, what role does data modeling play in machine learning and data science? So my background is more on relational databases, but the challenge, I'm sure, is very similar. That imagine this is your first day on the job, you come in, here's your username and password, get to work. Here are my databases, and I log in, I see a list of objects, I have all the right permissions. So here's my customer, and these are what, 8 different tables, but still, how do it just seems like orders and customers have something in common. So how do I begin piecing these together? So the question we get asked all the time at SqlDBM is, what can you do? How can you help me? I'm wasting time in meetings. I can't share this out to my users. I'm explaining the same thing over and over. And here's, this is our tool. It's a web-based tool. So it's very easy to share, very easy to invite, and there's no system restrictions. It runs just as well on a Mac as it does on a PC. And here's the same information, but displayed visually. So me as an analyst, I can take this and I can just say, okay, line item and order, or orders and customer. How are they actually joined? Okay, cust key, that's the common link. Let me get going. So in this case, this is actually the same Databricks project. So we do support the Unity catalog that you mentioned. We support Hive, which is the legacy Spark version. Unity, in case people are wondering about relational features, Unity supports, recently, about a year ago, released constraints, so primary and foreign keys, so you can declare them physically. And I'm sure that plays an important role in the way queries are optimized internally, but just for understanding, and as well as virtual relationships, which we offer on all projects. If you didn't want to create physical or you were using Spark, so we can propose these for you, we can create them for you, and you're able to at least get up and running analytically. Question to Ari is, how important is this in machine learning? So would a machine just have more variables would a model have just more variables to tune and find surprising inferences? Or does it make sense to understand it conceptually, even as a human, and maybe even normalize this into one data set that a machine can crunch through? How does that look like?
Yeah, great. And by the way, thank you for doing this. This is really cool to see people on the Databricks side seeing this for the first time. This is like an entity relationship diagram. And, at the primary basis, the first, question is like, I guess, like the better together story. So Databricks, great at, ingesting and transforming and doing the data modeling and doing the orchestration modeling of it. But you still need the business people to see, like, what is the actual data going to do? Like, what are the use cases? How do I structure the data? What type of information goes in? And that's exactly what you're seeing here with SqlDBM. Like, what are the names of the columns, which are kind of a human deciding what the description is, and then what type of data, like string, decimal, date. So that's what you're seeing. And then in terms of machine learning, and there's traditional machine learning where you're making a forecast, like what will sales be in the future based on the past, or you're doing a classification, who's most likely to churn. And that's where you need like the more data that you have, the magic of data science is those are called features or variables. The more variety of variables you have, I wouldn't say all the time, but much of the time, it could improve the model. You don't know, maybe it doesn't improve the model, but you want something where you can quickly, easily come up with an idea. Hey, we haven't tracked how much snow it is, and that might be affecting how people drive to the store, which could be lowering it. If you can then add, how much snow or traffic patterns, maybe it can improve your model. Maybe it was not your marketing that that hurt your sales. It was the weather. It may not be. It may be. But the point is, the more variables that you put into a model, it could help the like the accuracy of the model. But you still need humans to come up with these creative ideas, data engineers to figure out how to collect and then things like this. How do you join the data so that when you do the machine learning, it easily knows like what data are you pulling from, what type of data is it, and then the data science model will inform you something called feature importance. Which of these variables in this entity relationship diagram lead to the result, lead to better sales, lead to a more optimal price.
Okay. And are you at liberty to discuss some of the cutting edge or unintuitive or just kind of experimental things that you've seen Databricks clients do that are yielding surprising results?
Yeah. So we have over 10,000 customers. So my brain always races to which ones I should talk about. I love like Disney Plus streaming. That's another use case that didn't mention Lakehouses are good for, is like real-time data. Things are streaming on social media or in Disney Plus's streaming services. You're watching Star Wars movies and you can do just-in-time advertising or things of that nature. Video games, Riot games, etc. You're about or Supercell. I play Clash of Clans all the time. When you get connected to another player, you want to be able to like the Supercell, the video game manufacturer, Riot Games, they want to match you with somebody who's going to be a fun competitor. Number one. Another like use case that I forgot the word you use, but like fun, exciting, or surprising, or interesting is like toxicity detection. And so toxicity is, if you ever play Among Us, you get these like 7, 8, 9-year-old kids playing with older people like myself, and like a lot of younger kids curse and sometimes use really inappropriate language. So how can you detect that in real time and either ban them or like censor them?
You're saying you're protecting the adults from the kids in this case.
Yeah.
They're up on the lingo. They've got the latest slang. They just run circles around someone like me.
No cap. Yeah, no, exactly. That was like one, fun use case. And then I was with so we just had our summit in Chicago, which was a lot of fun yesterday. So we had a whole bunch of customer panels. So I'm sure I could pick any of those since we just spoke publicly, but like McDonald's has so many like 40,000 restaurants, and how do they do supply chain? How do they optimize their drive-through? There are all these jokes of how hard it is to hear people more French fries. Maybe you could use AI to help translate that into better natural language, which then could be put into a Databricks database, and since it's structured, be part of this entity relationship diagram. So it's like what the people said in the drive-through, match it with, our McFlurry machine's broken, and then have like just a guide to help the agent saying, oh, we're sorry, or McFlurry machine's broken. And it just helps the process. The consumers are happier, the stores are happier, and they're more likely to come back.
Okay, so these are examples of legitimate use cases that seem to at least have things figured out on their data science and engineering. In in my experience, and again, this is kind of limited to just traditional analytics and BI, there's always been a little bit of a disconnect between what the end user understands and can legitimately expect from you, and what the data team is able to come up with. So they don't understand usually the business as well as the SMEs. The SMEs don't understand the potential, but at the end of the day, we're still talking about things. The deliverables are things like bar charts and heat maps that once you see it, you understand it. So the art of the possible is not that far removed from, you could just sit down at a table and try to explain kind of cardinality and relationships to a user in a way that seems feasible, and then you can work towards providing something and answering their needs. But with data science and ML, let's say your organization is still immature in this department. So maybe even the data people that you have are not fully aligned to what they can potentially deliver to the business. So how would you go about facilitating those discussions to say, we don't have a data team to propose these interesting ideas.
Yeah.
We have all these crazy things like, I just want to magically know when a customer is about to churn. Can AI do that for me? How do you bridge that gap, or how do you have that conversation?
Yeah, that is the crux of enterprise analytics now, and I think it'll be more and more so as the years go on, and a lot of the easy parts of people's jobs get automated. There's automation of there is and will be of low level and entry level machine learning and data. So the complexity will move up. And to answer your point, you need people who are both know how to get the data, wrangle the data, and people who know the business. So how do you get them to collaborate? It's really a combination of having software that's collaborative. So like at SqlDBM, conceptual models versus actual specific models, technical models, and then having people with different personas. And I mean by that, a technical person, a programming person, and a business user, or even an executive, having these dashboards. You want them to be able to collaborate software-wise, but then, aside from the software, just in real life, you want to have a culture of natural curiosity, a culture of collaboration, and avoid, just purely top down. So the end result, the non-long-winded answer, I guess, is you want people from the top down who know the business, who can say, hey, I want to know when people churn. You want people from the bottom up to come up with ideas without just sitting there waiting to be asked. So you want your tech people to be naturally curious, come up with ideas of their own, and then run it by the management. Would this be helpful? You probably should have meetings where the art of the possible, the people working on the data modeling could say, here's the data we have, here's the type of insights we could provide. Are there any new things we could do? Are there any new data sources that exist? So if you don't have that collaboration and you're a pure data modeler, you only know what's in your purview, and you may not know, wow, there's a Nielsen or IRI that can get store data or survey data out there that if I add it to my data set could totally change the accuracy or what we can do. And then the other concept, which for me is the most fun, it was the most fun in baseball, the most fun when I deal with clients, and that's called feature engineering. So it's not just what data you have right now, in stocks, you have price and earnings, but what if you make a new column, price per earning? And in fact, if you're trying to predict a stock or the viability of a company, price per earning, depending on the question, is more predictive than the two columns. So it's either, and if somebody doesn't come up with that, you're going to miss that completely. You're going to miss having better insights. So feature engineering, like in baseball, or in soccer, let's just say, it's not just how quick was the player running, but with Lionel Messi, he's great at keeping the ball within 2 feet of him as he's running. So you make a new feature, percent of time ball is within 2 feet, percent of time ball is within 3 feet, within 1 feet. And then you run a data science model and see, does that help? And in what situations? So this feature engineering, sometimes the tech people are creative. You have to have a little bit of leeway of extra time for them to kind of experiment around. But sometimes it's the coach coming up with, like, they know how footwork and plays work. That's how I help kind of make my mark in baseball. I would sit with Rod Carew. I would sit with Oral Hershiser, Jerry Krause, others, watching a game, saying, just saying, what do you look for? And anything they look for that I wasn't capturing, which was a lot, as many years of my life, I would, if possible, capture that and make these new features. So that is what is going to give you a competitive advantage, is how do you take these features in the entity relationship diagram and make net new features, the combination of different columns.
Yeah. So I think the key feature or the key component of what you're describing there, or if you read between the lines, is trust. So they have to, the business has to actually trust that what you're telling them is going to be beneficial, meaning you have to come with a proven track record of having delivered meaningful insights or meaningful predictions in the past. Whereas most organizations, or I don't want to say most, but many, are stuck in this kind of chicken and egg problem where there's not a confidence in data. Therefore, the requests are very minimal. Just, give it to me so I make sure it has a download to Excel button. I know what to do. I'll do it in my own little silo. And there's never that communication. So in your experience, and again, where is that aha moment of, like in Hollywood and in Moneyball, of it's not working, and then suddenly they're getting on base? What does that look like? Did that actually happen in your own career, of you're sitting there in your cubicle and then suddenly, based on your advice, you're getting runs? But more importantly, how do you, and again, this is always going to be a people problem, not a technology problem, but how do you make sure that this chicken and egg cycle actually gets off the ground and starts maturing into data maturity, as they call it?
Yeah, trust. I love that word. Collaboration, culture. It's all about having an environment that people can be encouraged to fail. People could be encouraged to try different things. Like the one thing that makes, like, data science partly an art and partly the science is, there's a saying that no model is perfect, but some are better than others, or some are useful. It's knowing, when is it good enough that you're just going to make it production. Like for me, if it's like landing a rover on Mars, good enough means it has to land without and still be workable. But good enough in a marketing campaign, if not everyone does a click-through. If your click-through is below 100%, if your click-through is 10%, that might be great. 5%, like what time is it good enough? And at what point do you spend days, weeks, months, years to improve upon the model? So that's where the art comes through. But yeah, it's really about, how can you improve, how what questions are you asking, and how are you going about answering it? And then, like, the trust comes with, like, the explainability in the model and the explainability in the data. What version of data are you running? That's where Unity Catalog, why it's so popular, is you have this, it's called lineage. Is this data source old? Is this data from 2021 or not? Has the data drifted? Has it changed? So I need to rerun my model. Like the topic today is Gen AI. The topic a few years ago was COVID. If your store's closed, have 0 staff show up. Your model is broken. The store's not physically open. Or in baseball, I remember one young data scientist who would recommend trading for players, but the player was injured for the year and they just didn't have injury as part of their data set. And the GM looked at it and said, I'm not signing this player. They can't play.
Damaged goods.
Exactly. And so that was just since, the data scientist just didn't have injury as part of the model by not knowing, the industry. And so sometimes it's the data scientist that knows where the gaps are, and sometimes it's the business, but you have to have them all working together to get the best possible outcomes. The more data, generally, the better. Or it improves the chances of being better.
Okay. And given that we're almost coming up on time, I'd be remiss if I didn't prompt you to tell this story. But you made friends with a certain busker outside the stadium who just turned out to be a huge stats nerd himself. What prompted that, and who was he?
Well, I've had the honor, I know in some of the lead up to this, working as a talent scout, and actually I was in bands in high school, and some of my band members went on to play, in Tonic and Dishwalla and The Fray. But in this case, one of my favorite musicians of all the modern musicians, Eddie Vedder, huge Cubs fan, having worked in the front office, you get all these celebrities coming in, and my office was the first one after you get through the reception area in the front office. So all the people who would be singing or the national anthem or throwing out the first pitch, Michael Jordan and so on, would just kind of sit in my office. They were just the first desk. Their celebrities walk in and sit down. So it was it was a wild experience. Yeah, the Jonas Brothers taking batting practice, but he's a huge at heart, like literal fan. He knew all the players. At the time he was, he wasn't fully like hanging out in the clubhouse, but he would do that later. But, he would sit with me kind of in the owner seats and just talk about life and really poetic mindset. But yeah, and that case being outside, I'm sure there were videos on it. He would just kind of sit and pretend to be like, I don't know if he pretend to be a panhandler or just like play outside wearing a baseball hat, sunglasses, so people couldn't quite tell who he was. And then like his mouth opens and the songs come out.
Sounds a lot like Eddie Vedder, right?
Yeah.
Use a little bit of practice, we'll get there. That's cool. And
It was a fun story.
Yeah. And how, I guess we got time for one more. Since you also did scouting for baseball, but you also did scouting for music. And I would imagine those are very different skill sets. And could you even use your analytic mind for something like that? What does that look like?
Yeah, so there are some, like Live Nation and Sony and others that are trying to use AI to figure out like what existing bands, like is like a young 15-year-old Taylor Swift, like what genre, what type of personality might be popular, what time do you play music? Radio stations use it, use analytics to figure out what songs should get playing and tie it to advertisers. And there's music theory, which is math. I took music theory at Caltech and Occidental, and it's quantifying Beethoven and Bach to certain chord progressions. But then above and beyond it, there's that it factor, like what we were talking about, Hannah's question on clubhouse is good or bad with the Padres. Same thing in music. Are they going to be a good person to work with? Are they going to like get canceled or cancel you type of thing? Are they going to be likable a year from now, 5 years from now? That is something just still a human talent scout. I don't know how you can quantify that, but you can inform, hey, if you have 10 people that look like it to be the next it singer, how's their intonation and speed and stuff, that
Sure.
type of music would be helpful.
I actually have a related story. My favorite rapper I found randomly through a piece of data analysis. I didn't do the analysis. I just came across it on the internet. But they did token analysis to figure out the unique vocabulary of each rapper. And the guy at the end, he was just like off the chart, I'd never heard of. And just so happened, it's not that just because he's the most verbose, but he's, I don't know, just I really like his style. But it was just a really cool way to say, wow, like this is a quantifiable way to see like who's just more well versed in what they're doing. And also here, you can filter between all and just Wu-Tang Clan, proving
Ooh, nice.
proving the old adage, Wu-Tang Clan ain't nothing to with. Sorry, this is a family show,
Nice.
but the data supports the claim. So yeah, there's a lot you can do. So music theory, this is a whole, as you said, this is a whole discipline in science to see like how chord progressions and quantifiable, you can quantify music, but it seems like you can also do that with language. And these are,
Wow.
this is rap, but they also did something similar with what is the actual uniqueness by genre. So how repeatable are each of these? And you can kind of see why if you kind of sing about your pickup truck versus your Corvette and your
That is
Mustang
awesome.
here.
That's so cool. And it makes sense with rap that you don't want to repeat the lyrics. It's like if you come up with new words and that are different.
Actually, that's the inverse unintuitive conclusion. You do want to repeat the lyrics because, as you can see, rap is getting simpler and simpler by the decade. So
oh yeah, over time. That's interesting.
Yeah, all of the
Wu-Tang Clan on the right.
yeah.
Plus
If you
Boom
sort
Slugs
it
and Harmony.
by what's that?
I was going to say Boom Slugs and Harmony had such a unique style.
Yeah.
I would have thought their unique words were like way higher, but yeah, I like that trend year by year too. That puts it in perspective.
Exactly. Humans are visual creatures. So we're just over time and there's so much we can continue with. And I think that's enough for material for round two. But I just want to thank you so much for this amazing interview. It's been really spectacular having you. I hope we'll have you back at some point. And
Yeah, I'd love to. And yeah, I'd love to do that. Thank you for all the listeners. This was awesome. I love how you pulled up some of that to make it pop to life. And there's so much more to talk about. Hopefully follow us all on social media. We'll be sharing more of our adventures. And it was great to finally do this with you.
Well, absolutely. Pleasure's all ours. Thanks again. And thank you, everyone.
All right.
See you on the next one. Take care.
Take care.